Now, till now we have done for the conversion of galvanometer, sorry, into an ammeter or something like that, isn't it? Now we will start with, let us start today for the case of, and today will be almost, let us see till where we will complete. Today, the point is conversion of galvanometer into voltmeter. Okay, got it. Now, how to convert it? First point is that, so what we will do, we'll connect the galvanometer. We'll connect the galvanometer with a high, like in series, with, yeah, with, yeah, yes, high, with a high resistance. Got it, Anurag? What you do, just connect your galvanometer in with the particular a resistor which is of high resistance. Got it, Anurag? So let's suppose if I consider, right, this is galvanometer, this is resistance R, and let's suppose if I connect with, then this is going to become, basically I connected with series, then this is going to be called as a voltmeter. Right? Parallel. Yes, yes, yes. Very good. So look over here. Let's suppose if the resistance of galvanometer is Rg, okay, then the voltage drop over here is the voltage drop by the voltmeter. Got it or not? Is that clear? So this directly changes to, basically this is nothing but a voltmeter of high resistance. Got it? Is that clear? And voltmeter voltage V. Are you able to get me or not? Is that clear or not? So let's suppose if some current I was passing, this will pass through over here, and this is my voltmeter, isn't it? So look over here. If I want to write voltage equation, then voltage drop is equal to what? I into R plus, isn't it? Confirm? Now we know that for maximum deflection in galvanometer, we know that I is equal to how much? Ig, isn't it? And then, yes, and then the voltage will become how much? Equal to voltmeter. Are you able to get me around? So therefore, the relation is simple. That voltage of voltmeter is equal to galvanometer current into R plus Rg. Are you able to get me or not? So look over here. Voltmeter is measuring voltage. So basically, I can define my voltage sensitivity or not. So therefore, yeah, voltage sensitivity. Let's suppose this is Vs. It will be equal to how much? Like we define. Yeah. So I can write it as basically number of division by that also I can write, isn't it? So we got our understanding of how to convert galvanometer into ammeter, and it is its current sensitivity is N by Ia and voltage sensitivity is CS by R of ampere. And if I want to convert into voltmeter, it is I is voltmeter voltage will be equal to Ic into R plus resistance of the galvanometer. Is that clear or not? So let us do one question based on that. Try it. बोल रहा है कि convert the given sorry, convert the given galvanometer into first an ammeter of range 0 to 10 amperes, second voltmeter of range 0 to 10 volts. If for the galvanometer the maximum deflection current Ic is equal to 200 milliamperes and resistance of galvanometer is 10 ohms. Tell me. So basically, if I want to convert, I need to either add the resistance or either include the shunt, isn't it? So in the first question, if I want to create an ammeter, I need the shunt or not? So find the shunt. Yes. So first question they're asking about shunt. Second question they're asking about series resistor. Can you do it? Easy peasy. So in first one, which formula I'll use? Ic into is equal to ampere current minus galvanometer current into shunt. Yes. This is my formula or not? Yes. So look over here. I know my galvanometer current. It is 0.2 amperes, isn't it? The resistance of galvanometer 10 is equal to Ia. Ia maximally I want 10 amperes or not. So 10 amperes. Ic is once again 0.2 into my shunt. Good. So basically shunt is equal to 2 by 9.8. Means this is equal to 10 by 49 ohms, isn't it? But in which way? In parallel. In which way? In parallel with galvanometer. Are you able to get me? Second one, I need a voltmeter. So once again, voltage of voltmeter is equal to, I have the formula, maximum deflection in galvanometer R plus Rg. So once again, 10 is equal to how much? Ig is 0.2, R plus Rg is how much? 10. Right or not? Yeah, so this will come as R plus 10 is equal to 10 divided by 0.2 means 50, isn't it? So R is equal to how much? 40 ohms in series. Is that clear? Yes, yes. Okay, can I move ahead? Now look over here. So we got to know there are four different cases we got to know today. Like in this whole series, verification of Ohm's law, then our understanding of rheostat, current source, rheostat as a variable voltage divider and all, and galvanometer, then galvanometer as ammeter and voltmeter. Got it or not? The next experimental setup is my multimeter. Sorry, meter bridge. Yeah. So I think this is fifth one, isn't it? Now, as we see, it has so many important components, isn't it? First, there is itself a long 100 centimeter wire, wide or not? Yeah. 1 meter? Yes, correct. So, and it is connected with two important things of physics, which we call it as a resistance box and then a shunt box, wide or not? Got it? So, here I have this shunt box, wide or not? And then here I have resistance box, wide or not? This is my RB, this is my sun, here is my point point B where the jockey is connected, and with this a battery is connected. Got it? Now look over here. As I have this jockey, so this jockey is connected with a galvanometer and it is pointed somewhere over here, isn't it? Well done. So let's suppose if this length is L, correct, isn't it? But this is in centimeters, isn't it? We need to remember that this is in centimeters. Got it? Isn't it? So I have L and 100 minus L and some potential of the battery is given to you. Are you able to get me or not? So basically, let us write some points regarding this. That it is based on the principle of Wheatstone bridge. Yeah. It is based on the principle of which bridge? Wheatstone bridge. Okay. And second thing is that it is utilized to find the unknown resistance, isn't it? Isn't it? Take. So now let's call this point A, and this point is C. So AC is a 1 meter long wire, isn't it? RB is my which thing? Known resistance. Yeah, resistance box or या फिर known resistance. Yes. Yeah, shunt is my unknown resistance. Yeah. Are you able to get me or not? Now, as wherever this jockey will balance it, we know that it is like a Wheatstone bridge. So S into L will be RB into 100 minus L or not? Yes, yes, yes. So basically, we write the formula we'll just convert this into like a Wheatstone. Got it? So let's call this AD. Let's suppose we call it as P, or let it be R only. Let it be R. This is S, and this is P, and this is Q. Got it? P and Q. Are you able to get me? So then it is like a Wheatstone bridge case or not? Let's draw. Yes. So let us draw a Wheatstone bridge to make it perfect. Or we can do one thing. Let's take one square. Isn't it? This is like this way. Yes. Here one of the resistance is there, which is R. Here another resistance is there, which is S, which is unknown. Here minus P is there, but P, can I write it as rho into length L? Where rho is my resistivity, isn't it? Or let us define another quantity. Let us not no need to area. I'll include this. I'll write it as lambda. So let us define one quantity called as lambda, and we call it as resistance per unit length. Word or not? Are you able to get me? Then call, let's suppose, Q. So this Q will be equal to what? Lambda 100 minus L, isn't it? And then I have a galvanometer connection. No resistance need to be considered. Okay. Then at the balance condition, we know that R into Q is equal to P into S, isn't it? So basically, unknown resistance S will be equal to what? R into Q by P. So R is what? R given. Q is lambda lambda will get cancelled, so 100 minus L divided by this P. P is L, isn't it? Where L is in centimeters. Remember that this L, if I include 100, then L is in centimeter. Is that clear? Are you able to get me? So look over here. Let us try to write some point that what is the important property of meter bridge, such as to why not we are using Ohm's law, but using meter bridge to find the unknown resistance. There is important property. Go ahead. point is, first important point, write these points in a very good way. They're not available in any books. First thing, we can interchange the position of galvanometer and battery. First point, I can bring this battery instead of galvanometer and galvanometer instead of battery, but nothing changes because there is no current in that one. Void or not? Yes. So second case, for least error, as you know that in the experiment the error will be there. So for least error, remember that we keep the balanced length L. For least error, we keep the balanced length L between 40 centimeter to 60 centimeter. Means this length, this jockey length, such to get lowest error, we keep it where? Between 40 and 60 centimeter. Are you able to get me or not? Because see, 40 and 50 is almost near 50 and 50 or not. So it will balance the both sides. Because exactly 50 is in reality not possible. Hmm. There should be a resistance. There should be some kind of error, isn't it? Depends on external factors. Third case, balanced length. Got it or not? It's in reality, how come it is possible? You only say me. If the temperature is high, resistance will become more. If the temperature is less, resistance will become less. So how come it will be between few? टेम्परेचर्स पे डिपेंड करेगा, बैटरी पोटेंशियल पे डिपेंड करेगा, बहुत सारी चीज़ों पे वो डिपेंड करेगा, एरिया ऑफ द क्रॉस सेक्शन ऑफ ये थिकनेस क्या है इसका उसके ऊपर डिपेंड करेगा. इसलिए हम 40 to 60 रखते हैं प्लस माइनस 10. ओके. यस. यस. थर्ड पॉइंट, द बैलेंस लेंथ L does not depend on lambda. This balance length over here will never depend on this lambda. Yes, right or not. So basically, this means that it does not depends on first thing material thing or cross section of wire if wire is uniform. It will not depend on cross section if the wire is uniform. If it is non-uniform, then this is why balance length will change. Are you able to get me or not? Got it? Now, as you know, that in the end, if I am joining this, so this ends have like we roll like this way, isn't it? So ends will have also some current which will increase the resistance or not. So point. So note this that if end corrections, sorry, are A and B, means if in the end I have left some length, void or not. So A and B centimeters, void or not. Then total length becomes then total length becomes 100 plus A plus B centimeter. Are you able to get me or not? Is that clear? Yes. So now if I include the length, basically, see, if the end corrections are included, the total length is 100 plus a plus b. So a is present over here, isn't it? B is present over here. So a will change the L to L dash or not? So L dash is equal to L plus a, void or not? While this B will change 100 minus L. So 100 minus L dash is equal to 100, original 100 minus L plus B. Void or not? Is this clear? Now, the question arises, why only 100 centimeter we use? The reason for this is, as we use the longer wire, what happens? Errors increase, sensitivity increases. Are you able to get me or not? So we can use, basically we will not use less than 100, but we can use more than 100 definitely, and this will give you a much more accurate results. Are you able to get me or not? Yes. So this is why potentiometer was developed, na? Okay. Okay. So can we do some questions? Okay. बोल रहा है in meter breeze experiment बोल रहा है known resistor R is given 100 ohms. Void or not? Balance length is 48 centimeter. बोल रहा है if end corrections are A is equal to 2 centimeter and B is equal to 3 centimeter, then find unknown resistance. Then find unknown resistance. Do it fast. One. Yes. Tell me, what's the answer? How much? 1 1. Let me check. Acha, end correction means I know L dash. L dash is how much? 48 plus 2, isn't it? Which is 50. And then if we look for, yes, so therefore 100 minus L dash I need to include. Sorry, 100 minus L dash is 100 minus L plus B, isn't it? So how much is that? 100 minus 48 plus 3. So I think this is once again uh, 55, isn't it? Are you able to get me? So then I can apply now. X is equal to R means 100. 100 minus L dash, that is 55, divided by 50. 0, 0 cancel. 110 ounce. Got it? Next. बोल रहा है in once again in MB experiment, okay, resistance is equal to 60 ohms, right or not, and unknown resistance is X. Got it? बोल रहा है find X balanced length if balanced length is shifted by 20 centimeter if case 1 R and X is interchanged. Second case, R is shunted by 48. Do it fast. 1 minute, I'll take some break, okay? Do it fast, okay? One minute.